Imagine an individual wishing to set up a trust fund that will pay to some organization $500 every 3 months, even after his death. So the wish is that these payments of $500 every 3 months to the given organization continue on forever. And we assume that, or we will be assuming that, the investments are carried with an 8% annual interest rate. So we can visualize this quite easily on to a timeline. So we have time 0, and the question is, what must be the initial investment so that it can sustain forever a payment of $500 every 3 months to the given organization. So after 3 months, $500 will be withdrawn from the trust fund. Now here I will label this 1, but keeping in mind that our intervals of time correspond to 3 months. So 3 months later, therefore, after 6 months, again, $500 will be given to the given organization. After the 3rd period, therefore 9 months, again $500. After the 4th period, therefore 12 months, after a year, 500 again, and this will go on forever. So the question is, what must be the value of the initial investment? Well, first let's figure out what is the interest rate for a given time interval. Now, as we've just said, each interval corresponds to 3 months, but 8% is an interest rate for a year. Well, in 1 year, you can fit 4 periods of 3 months. So if money grows by 8% for 1 year, for a quarter of 1 year, it will grow by 2%. %8 over 4, of course, is 2%. If you prefer, 0.02. So this is now the growth rate over a period of 3 months, which is what we're after. So, how do we figure out the initial value of the investment? Well, the idea is, this initial investment of x at time 0 is supposed to amount to the exact value of these payments of $500 forever. So if we bring back every single payment of $500 to time 0, we will have the value of the initial investment. Therefore, the present value of all of these payments of $500 is exactly the value of the initial investment for this trust fund. Well, so x will be equal to, well, we have to bring back $500 here by 1 unit of time, 3 months. The interest rate is 0.02 for such a period. If we moved forward by 1 unit of time, it would be 500 times 1.02. But as we're moving backward by 1 unit of time, we have to divide 500 by 1.02. Plus, well, bring this back to time 0, the present value. We have to bring 500 back by 2 such periods of time. So it will be divided by 1.02 twice. Therefore 1.02 squared. Plus, the third payment of $500 must be brought back by 3 units of time. So it must be divided by 1.02 3 times, so 1.02 cubed. And this will go on forever. 500 over 1.02 to the 4, 5, 6, 7. And as we want these payments to continue on forever, what we now have is an infinite series. The great thing is, it's an infinite geometric series. So we can write this very concisely. This is the sum. Well, the terms look like what? I will break up the 500 from the 1 over 1.02. and n begins at 1, and as we have an infinite series, n goes on forever, so up to infinity. This is a geometric series where r is 1 over 1.02. This is positive and strictly less than 1, therefore we have here a convergent geometric series, which we can therefore evaluate using the summation formula. If you recall, for an infinite geometric series, the summation formula is simpler than the one for a finite geometric series. And the corresponding summation formula is quite simply the first term over 1 minus r. So the first term, of course, here is when n is 1, which gives us obviously 500 over 1.02. This is the first term of the series over 1 minus r, 1 minus 1 over 1.02. And if you evaluate this with your calculator, you will find exactly $25,000. And that's it. So, if a person wishes to set up a trust fund that will pay to some organization $500 every 3 months forever, the initial investment, if we are allowed an 8% annual interest rate compounded every 3 months, will give us a 2% interest rate for such a period. The initial investment to sustain this infinite number of payments of $500 must be exactly $25,000. And that's it.